Hello, my name is Abby White, and I'm the Project Manager and Structural Engineer for OKAE Engineering. With me today are the other talented members of the OKAE Engineering Design Team. To start off, we have Katie Schreiner, our Transportation Engineer, Ellie McCulley, our Water Resource Engineer, and Olivia Holtz, our Environmental Engineer. And today, we're excited to present to you our current park report for the Phase 1 portion of the Amazon Industrial Park project. This project includes the design of the Amazon warehouse facility as well as a new connector road from County Road 17 to County Road 19. We will also be implementing stormwater management practices to prevent flooding and to treat stormwater pollutants. Additionally, we will also be designing a wastewater treatment facility to reduce contaminants before discharge. And to begin, the structural department at OKAE Engineering has been tasked with designing an Amazon warehouse facility. The proposed building will be a one-story structure covering approximately 50,000 square feet and will include spaces for warehouse spaces, office areas, reception areas, packing and shipping areas, equipment storages, unloading and loading docks, and auxiliary spaces. For the Phase 1 portion, I needed to determine the optimal location for the warehouse, as well as establishing the load requirements to ensure its functionality and efficiency. This analysis was crucial for meeting the needs of the warehouse as well as adhering to regulatory and safety standards. I will ensure compliance with the various different building codes and regulations, such as the International Building Code, the American Society of Civil Engineers, and specific regulations from Elkhart County. I will also be following different material codes from the American Institute of Steel Construction and the American Concrete Institute. And lastly, I will evaluate and develop different alternatives for the project by assessing various different design and material options in order to determine the best alternative for the warehouse. Currently, I've conducted a site evaluation to assess the land suitability for the warehouse. I have chose the southeastern portion of the site as it provides ample access for truck access as well as minimizing disruption to existing site conditions, and it is positioned the highest reasonable elevation to facilitate drainage. I've also determined the live load requirements, explored various different design alternatives, and ultimately selected steel and reinforced concrete as the most appropriate material selection for the project. I've also explored various different floor plan alternatives for this project, and throughout all of this, I've stayed compliant with various different building codes and regulations. As you can see here, the table to my left, you can see the approximate live load requirements that I've gathered so far of this portion of the project. And you can see that I referenced it from ASCE, which is the American Society for Civil Engineers. The first alternative will be a one-story steel structure and will include designated areas for warehouse storage, office areas, reception areas, equipment storage, packing and shipping areas, unloading and unloading docks, and auxiliary spaces. The office area will be approximately 5,000 square feet and will be located at the southern end of the building, while the warehouse will be approximately 45,000 square feet and be located at the northern end of the building. The square footage for each area will remain consistent across all three different alternatives, but will vary depending on the location of each alternative. This design will feature long span roof trusses, beams, columns, girders, and girts. And the long span roof trusses will be used to help create a large open space by minimizing the need for interior columns. The second alternative is a one-story reinforced concrete structure, and while the floor plan will remain consistent with the first alternative, it will vary based on the location of the areas and the structural framework. This design will feature beams, columns, girders, and shear walls which have been used to help protect against any lateral loads. The third alternative is a one-story steel structure and will use the same designated areas as the previous two alternatives. The main difference in this design is the location of the areas, as the office area will now be situated at the southeast portion of the building and the warehouse will be positioned at the west end of the building. This design combines multiple elements from the previous two alternatives, and instead of relying on long span roof trusses to hold the roof, it will utilize the framework of beams, columns, girders, and girts. In the upcoming weeks, I will continue the preliminary design for the Phase 1 portion of the Amazon Industrial Park project. And specifically, I will focus on the structural framework layout of each alternative. I will then evaluate each alternative, complete a cost analysis, and then conclude with the alternative selection for the best selection for the warehouse. I would now like to pass the torch on to Katie Schreider, the transportation portion of the project.
Hi everyone, as Abby mentioned, my name is Katie Schreider and I'm a transportation engineer with OKAE Engineering. For this project, I was tasked with designing a new connector road going from County Road 17 to County Road 19. This road will provide access to the new warehouse that is to be developed on the eastern end of the site. In addition, I am also in charge of development of any and all parking structures related to the site. These structures will be developed in accordance with the Indiana Design Manual, the AASHTO Green Book, and any and all Elkhart County codes and regulations. In addition to the scope, I was provided with a previously conducted traffic study that described how the intersection should be designed. The first intersection is between County Road 4 and the toll road. For the eastbound leg of the first intersection, it is to have one right turn lane and one through and right turn lane. The northbound leg will have 2 left turn lanes and 1 right turn leg. And the westbound leg will have 1 through lane and 1 left turn lane. This intersection is to be signal controlled. On the eastern end of the site, there is the County Road 4 and County Road 19 intersection. This intersection is to be stop controlled. Per the scope, we're not supposed to alter County Road 19 in any way, so we'll just be adding on County Road 4. This intersection will have 1 left turn lane and 1 right turn lane. This is a sample parking layout for the site. This is based off of structural alternative 1 and 2. As you can see, there are 3 different parking lots. The first parking lot is located near the office building at the front of the site. This parking lot will be one-way and feature angled parking to easily access the office space. The second parking lot will be on the right side of the site exclusively for cars. This will help provide better access to the warehouse portion of the site. The third and final parking lot is located at the back of the site, which is for trucks to unload and reload material. There's also additional parking provided for any vehicles that are currently not in use. This design will be seen on all transportation alternatives that I've recommended. My first alternative aligns the new road with the existing east-west roadways. It puts the new road to the south of the new warehouse and prioritizes geometrics rather than access to the toll road. This road is also further away from the wetlands located to the northern end of the site. My second alternative keeps the new road in the same spot but emphasizes the County Road 4 going into the toll road. It emphasizes the County Road 4 into the toll road, and it keeps the road away from the wetlands located to the northern end. My third alternative moves the road to be north of the warehouse. This will, again, realign the road with County Road 4 and any other east-west roadways. And the final alternative realigns the road with keeps the existing infrastructure and moves the road to the north of the warehouse. All of these road designs are two lanes, 12 feet width, and with a 10-foot shoulder on either side. These roads are also all designed to have a 45-mile-an-hour speed limit. My future work includes finalizing the geometrics such as the parking lot design and the profile of the roads. I also need to design a signal timing plan emphasizing the peak hour timings and develop a cost analysis. This will include cut and fill of the existing land, auxiliary lane length, and material cost of the site. At this time, I'd like to pass on the presentation to my colleague, Ellie McCauley.
As mentioned, my name is Ellie. I am the Water Resources Engineer for OKAE Engineering, and I have been tasked with stormwater management throughout our site. There are two parts to this task. First is minimizing stormwater runoff or controlling flooding, and the second is treating stormwater. This is broken down more specifically with the goal of 80% of total solids being retained and 65% of total phosphorus being retained. This will be done in compliance with local and state codes. Primarily, this will be the Elkhart County street standards with a secondary emphasis on the Indiana Design Manual. And we will use these to develop and evaluate three different alternatives that will be shown today. Current work, we started off with site evaluation. We looked at different flow paths and best practice managements that would go well with our soil classification of A, which means it's ripe and ready for infiltration. We also looked at volume estimation for our water quality volume from the impervious surfaces. We have that volume coming in at about 35,000 cubic feet. For flood control volume, from the total site lot area, we have at about 300,000 cubic feet. And then finally, our design alternatives will, with the detention and retention ponds, will primarily look at volume control. But we also want to take into consideration all of our pollution concerns. All of the BMPs looked at today will in some way reduce our solid and phosphorus load. Luckily for us, a lot of the particulate phosphorus will settle out with those solids. So we'll be looking at special notice of which of our BMPs can remove some of that dissolved phosphorus to get a larger percent retained. Starting off with the first alternative, we have our detention pond. This is going to come in at about 51,000 square feet for settling out those particulates. We have permeable pavement, which will be a great infiltration practice, and then vegetative swells, which will be for bioinfiltration. As you can see, we have starting at the top of the roadway, going through vegetative swells on both sides, and then our water making its way through the site, off of the buildings, onto our permeable pavement. Inside the permeable pavement parking lot, we also have another vegetative swales area, and then finally it will go into our detention pond. Our second alternative features two detention ponds with about 16,000 square feet each. We also have a sand filter with iron shavings. This one is really meant to condense some of that dissolved phosphorus. And then we have rain gardens at about 17,000 square feet to do some bioinfiltration, and then an infiltration trench. This one's a bit unique because it splits the roadway in two. We have a detention pond on each side of the roadway. On the bottom side, you can see that our infiltration trench will pick up some of the stormwater beside the road and then go into that detention pond at the bottom. And then on our top side near the site, we have a sand filter with those iron shavings, the rain garden, and then the detention pond. And finally, alternative three, we have a retention pond at about 104,000 square feet. We have a green roof for some further infiltration, and then floating treatment wetlands inside the retention pond to work on the dissolved phosphorus, and then some vegetative swales. So again, we have the same kind of setup as the first one, vegetative swales alongside the road. The green roof is really going to capture and infiltrate some of that stormwater that's coming off the building itself, and then we'll all make our way to the retention pond with the floating wetlands. Finally, for future work, I will be working on efficiency estimations, cost analysis, evaluation of alternatives, and incorporation of the outside watershed. I would like to pass it off to Olivia.
Thank you, Ellie. As mentioned, my name is Olivia Holtz, and I'm the environmental engineer for OKAE Engineering. So the environmental aspect and scope for this project is designing a wastewater treatment facility for this Amazon industrial park, and it is going to be able to manage an average of 1 million gallons per day of flow. I also need to make sure that I'm in compliance with all regulations, both state, federal, and local, so I'll be using the EPA's reference and the American Legal Publishing, and as well as different local regulations. Finally, I also am looking into developing and evaluating alternatives, as biological treatment is the part of wastewater treatment. Those have been the main things that I've been looking at thus far. So my current work has been just doing research on the regulations and maintaining compliance with them. And then the size and location determination for the wastewater treatment facility. As you can see, it is currently proposed to be on the southern border of the site bound, and it is roughly 80,000 square feet, but that is subject to change as my design alternatives have been chosen. Finally, I've been looking at the design alternatives for the biological treatment as mentioned, and I would love to go into that for you guys. So my first alternative is for trickling filters. Some of the benefits to using trickling filters is that they are low in energy consumption, which in the end will reduce cost overall. And then they also have a reduced odor generation, which is lovely for any neighbors that are nearby or anyone driving past. Since we are kind of like a little bit out there, it's not too much of a worry, but always a benefit, especially for those working. The treatment efficiency for biochemical oxygen demand, or BOD, is about 70 to 90% when using trickling filters, which isn't the highest, but it is still pretty good. The other thing is that the biofilm control for trickling filters is a little bit hard to manage. Sometimes the biofilm does get a little bit out of control, so we have to have maintenance go in there to make sure that no clogging happens or occurs. Finally, the effectiveness as temperature decreases also decreases. So since we are in Indiana, it's obviously going to be cold during the winter months, so it's going to kind of let the efficiency go down, so that's another thing that I have to keep an eye out for. My second alternative is using a rotating biological contactor, or RBC for short. This one also has low energy requirements, again, keeping that cost down, helping it overall. It also provides more compact design, which helps to reduce the amount of space needed for the wastewater treatment facility. And this one has the same 70 to 90% BOD removal efficiency. And then the downside to rotating biological contactors is that they do require routine maintenance, which is going to end up affecting the cost overall, bringing in maintenance, making sure that everything is fully functioning. And then they are also a higher initial cost, which again, obviously will bring that cost up to start, but then maintenance throughout is a little bit lower than how some normally are. So then my third and final alternative is using activated sludge. The treatment efficiency for this one is the highest overall at 85 to 95%, which is really great to see. And then this is the customary method of biological treatment for wastewater treatment facilities, and the source that I found said that it's upwards of 90% of wastewater treatment facilities use this. And the downside to activated sludge is that there are sensitivity changes, so like temperature, pH, the amount of influent, that's kind of something to take into account as well. And then same as some of the others, it does have high energy consumption, which will then in turn increase the amount of cost overall for the project. So in order to evaluate these alternatives and decide which is the best fit for this wastewater treatment facility, I'm going to be using cost, performance, operational management, effluent discharge, land needs, and time, and I'll be doing a weighted average of these in my matrix that you can see pictured here. I decided to do the weighting based on which I thought was the most important, so obviously cost and performance are going to be the most important overall, taking up 50%. So this will be something that I'll be looking into moving forward. So additionally, moving forward, my future work will include evaluating those alternatives as mentioned, and then selecting those alternatives, as well as then completing the cost analysis once all the rest of the treatment train has been finalized, and then finalizing the treatment train design overall. And I would like to pass it back to Abby to wrap it up.
As you can see here, this is the phase 1 cost estimate for the OKAE engineer. We have split it up into 4 different categories, starting off with task, hourly rate, hours worked, and total cost. You can see here the hourly rate already includes the profit and overhead costs, and the hours of work are the OKAE engineering's estimated amount of time that we think it will take to complete the phase 1 portion of this project. We then compiled this all together. We got a total cost estimate of approximately $67,600. Anybody have any questions?
Yes, very nice presentation. Yes, thank you. My question is from an environmental point of view. The big issue in this northern part of Indiana, correct? Do you already figure out what type of soil do you have? Yes?
Yes.
Normally it's kind of highly clay and prone to flooding. And all these towns are having those problems. What kind of alternatives do you have to take care of that potential flooding?
Well, the flooding, I think the detention and retention ponds are going to be our biggest issues for the flooding. We do have the wetlands located near enough, so if we will have some kind of overflow spillways if we have to go into the wetlands. But overall, the detention and retention ponds, are the different. Yeah, so detention and retention ponds primarily located behind the building. The idea is that we'll channelize all of the water coming onto the site through and to those detention and retention ponds.
Thank you. Second question is for the transportation person. These days, around the United States, everybody's trying to avoid the silica exposure of the workers, and they don't want to cut concrete in place. So are you considering to put the sensors below the intersections to detect the traffic, just for the future? To prevent that somebody has to came with a big disc to open the big holes for the sensor cable below the intersection.
I have not looked into the type of detection for the signals yet. However, I do know that Indiana likes to use the inductive loops in their pavements a lot, but I know a lot of other states, such as Missouri, where I'm from, prefers to use cameras or radar. So I'll be doing some more research into that.
Well, Ellie, you had a couple of questions. So the permeable pavement, is that the travel lanes of the main road going through?
No, it was on the parking lot, so
Okay.
yeah, alternative with sorry, the alternative with the permeable pavement, that's the parking lot that kind of goes around the building with the vegetative swells located inside of it.
Okay.
I had already developed this alternative before we talked about the shoulders in class. We did potentially think about doing that,
Yeah.
but I think that this would be best just for the commuter parking lot, just because the heavy truck traffic may not be the best for permeable pavement.
And then, are you thinking of doing the whole lot, or just the parking stalls, or?
Just the two parts that were considered for vehicle traffic only, so not the large trucks, not the loading and unloading areas. So like if you go back to the parking lot design, I think the idea is that this area will be for primarily larger truck traffic, so this would not be permeable pavement, but these two would be for commuter vehicles.
So even like the travel lanes in those lots? Or
Yes.
just, okay. Okay. And then, so the detention ponds have an outlet, right?
Yes, it's gonna be a little bit different depending on where the building ends up being settled. The ones that we use for this one has the detention and retention pond there, so it will outlet somewhere on the north side of the site, but then we have, if the building ends up being on the other side and we go on the southern side of the site, it's gonna kind of change where it's outletting to.
Okay. So just comment, you might want to think about just doing the parking stalls in the parking lot for
Okay.
permeable pavement, because when cars turn in and out of, there's a lot of abrasion, and that's where it fails first usually, so.
Yes, Professor?
Yes, the big debate about having parking lots next to protected areas like these wetlands is where is going to go the runoff from the parking lot. Yes, and of course the parking lot, you know what means fluids. Yes, the antifreeze leakage, of the gasoline and the oils, they are going to go. What are your plans to take control of all that? Yes, contaminants from the parking lots, where they are going to go?
Yeah, that's where I think that some of the infiltration practices will come in well. I think that's why permeable pavement could be a really good option for the parking lots, just because then you're infiltrating into the ground and at least some of it's retained, so it's considered somewhat managed. However, that's definitely a consideration and something that we should look at. However, the scope does focus on contaminants from phosphorus and solids, so that's what the client has requested.
I really hope that you are not going to consider to take the contaminants to the ground through the permeable concrete. My point is that is going to be considered storm water, and normally the storm water has the notorious idea to go directly to the creek, and you don't want that. Yes. For example, Walmart decided Supercenter in West Lafayette, and they did the mistake of not considering that next to a block that was a protected area. And that's my point. So they had to do a kind of a channel that is going to absorb with vegetation to absorb that. that's why my point is, please do not take the leakage or the parking lots to the permeable concrete. They have to be taken and treated because they are going to have contaminants. So that's my suggestion for your final. Thank you.
Thank you.